This will just be a quick video showing you how to walk through the unit conversion problems. So these two examples were on a previous slide, but I'll just go through them in detail on here for you guys to follow along with. So first off, you should all have those unit conversions written down in your notes on that sheet of paper, and they're also available for reference earlier in the slides. So we'll start with this first one up top here. So we need to know the unit conversion for atmospheres to millimeters of mercury. So I know that 1 atmosphere equals 760 mmHg. So now to set up this problem, you just draw that handy dandy table. And the easiest way I think to do this would be to put those units in place, because whichever unit you want to get rid of, you want to have it one on the top and one on the bottom. So I know we start out with 7.4 atmospheres, and since I want to eliminate the unit of atmospheres, I know I'll have to put that on the bottom. And since I want to be left with mmHg, I will place that in the top. So then this is where that conversion factor comes into play. So 1 atmosphere equals 760 millimeters of mercury. And now since we can just read this right across the top, since they're both on the top, we can just multiply 7.4 times 760, and we get the answer 5,624 millimeters of mercury. Since there is an atmosphere unit on the top and on the bottom, they will cancel each other out, leaving you with just mmHg. So now on the next problem, we need to know the conversion for atmospheres to kilopascals. So I know 1 atmosphere equals 101.3 kilopascals. So we'll set it up the same way. We start off with kilopascals, 18.2 of them, and since I want to get rid of that unit, I will write it in the bottom, and I want to be left with atmospheres, so I'll write that in the top. So now I will fill in these conversion factors. 1 atmosphere equals 101.3 kilopascals. So now since this number is on the bottom, if you read this from left to right, you will have to divide 18.2 divided by 101.3. So basically this equation turns into this, to put it simply. And that will give you 0.18 atmospheres. And since there's a kilopascals on the top and on the bottom, they will cancel out, leaving you with just atmospheres.